Imagine you're an astronaut, floating in the silent vastness of space, Earth a distant blue marble behind you. Suddenly you sense a pull, not a sound or vibration, but a force tugging at your ship and your very being. You've drifted too close to one of the universe's most powerful mysteries, a black hole. The pull intensifies, your engines straining in vain against an invisible current. Stars ahead warp and bend, their light smeared across your view screen. Before you, a perfect, absolute blackness devours the stars, a cosmic abyss. Around it, a glowing halo of superheated gas and dust, the accretion disk spins in a final fiery dance. Colors you've never seen swirl in a dizzying spectacle, the last light before matter vanishes forever. Escape is impossible. Your journey has begun. You're no longer a spectator but a participant in one of the universe's most extreme events. The hum of your ship is the only sound as the laws of physics are about to be tested and broken. What lies beyond that dark edge? What secrets does the universe hide within that abyss? You're falling, accelerating toward the ultimate unknown. The universe is about to reveal one of its deepest secrets. This is not just a fall, it's a cosmic adventure into the heart of darkness. Every instinct screams to turn back, but there's no escape. You are on a one-way trip into the most mysterious place in the cosmos. The ultimate plunge has begun. So what is this cosmic monster? A black hole isn't a hole in the usual sense. It's an immense amount of matter packed into an impossibly tiny space. Imagine a star many times heavier than our sun, crushed into a sphere smaller than a city. Its gravity is so intense that nothing, not even light, can escape. That's why it's called a black hole. Light goes in, but never comes out. It's not empty. It's the densest place imaginable. Gravity here warps space-time into a bottomless pit. At its heart lies the singularity, where matter is crushed to infinite density and physics as we know it breaks down. The laws of gravity and quantum mechanics can't explain what happens here. Is it a point? A ring? We don't know. The singularity is the ultimate frontier, hiding the universe's deepest secrets. Falling in, you're not entering nothingness, but the most extreme concentration of mass and gravity possible. The black hole is the universe's ultimate prison, gravity is the warden, and escape is impossible. It's a place where space and time themselves cease to exist. A cosmic enigma, wrapped in a gravitational mystery. Where do black holes come from? Most are born from the death of massive stars. A star at least 20 times the mass of our sun burns bright for millions of years, fusing elements in its core. When it runs out of fuel, gravity wins, and the core collapses in an instant. This triggers a supernova, an explosion that blasts the star's outer layers into space. If the core is heavy enough, it collapses past all limits, forming a singularity, a black hole. Gravity has triumphed, leaving behind a scar in space-time. There are also supermassive black holes, millions or billions of times the sun's mass, lurking at galaxy centers. How they form is still a mystery. Did they grow from smaller black holes or collapse directly from giant gas clouds? Whatever their origin, every black hole is gravity's ultimate victory. They are the universe's most extreme objects born from cosmic destruction. As your ship nears the black hole, Einstein's relativity takes over. Time slows for you compared to distant observers. Your seconds stretch into years for those watching from afar. This is gravitational time dilation. To you, time feels normal, but the universe outside races ahead in fast forward. Approaching the event horizon, the point of no return, escape becomes impossible. The event horizon isn't a wall, but an invisible boundary where gravity's grip is absolute. Cross it and not even light can escape. Before crossing, you could theoretically turn back with enough power, but once inside, all communication with the outside world is lost. You're cut off, isolated, on a one-way journey to the singularity. The universe outside becomes unreachable, a ghostly memory as you plunge deeper. Crossing the event horizon might feel strangely uneventful. For a supermassive black hole, the crossing is gentle, no bump, no flash. The universe behind you warps, squeezed into a shrinking patch of sky. Inside, your fate is sealed. The singularity is now your future, not a place you can avoid. Looking back, you'd see the universe's history compressed and distorted. Ahead, only darkness. No light escapes from the center. You are utterly alone, cut off from everything you've ever known. No message can escape, you are a castaway in warped space-time. The outside world is gone. Your only path is inward. The final descent has begun. For smaller black holes, your doom begins before the event horizon. The process is called spaghettification. Gravity's tidal forces stretch you into a thin strand. Falling feet first, gravity pulls harder on your feet than your head, stretching you longer and longer. Your ship is torn apart, metal and flesh alike pulled into a stream of atoms. For stellar mass black holes, this happens outside the event horizon. You're destroyed before you even cross. For supermassive black holes, you might cross intact, but the stretching comes later, near the singularity. No matter the size, the end is the same. You're pulled apart, atom by atom. Gravity's power is absolute, and escape is impossible. Spaghettification is the final act of your cosmic journey. The black hole consumes everything, leaving nothing behind. This is the ultimate destruction. Is there any escape? According to physics, no. But some theories offer a glimmer of hope. Enter the wormhole, a theoretical shortcut through spacetime connecting distant points or even different universes. A black hole could be the entrance, a white hole the exit. But wormholes are purely theoretical, no evidence exists, and they'd likely collapse instantly. Even if they could exist, you'd need exotic matter to keep them open, something we've never observed. The journey would be perilous, with extreme gravity and radiation. For now, wormholes remain science fiction. The scientific consensus, falling into a black hole, is a terminal event. There's no sequel, just the end. The cosmic subway remains closed. What if black holes are more than cosmic traps? Some theories suggest they could be gateways to new universes. In the multiverse hypothesis, every black hole might spawn a new universe with its own laws of physics. Instead of crushing matter, the singularity could bounce, creating a new expanding cosmos. Our universe might have been born from a black hole in another universe. If true, falling in isn't the end, it's a transformation. You'd be broken down, your information recycled as the foundation of a new reality. These ideas are speculative, but they push the boundaries of science and imagination. String theory hints at extra dimensions. Maybe black holes are portals to higher realities. We're deep in the realm of what if, where science meets philosophy. Black holes may be more than endings. They could be cosmic beginnings. What do we truly know about black holes? The honest answer, not much. No one has returned from beyond the event horizon. Our knowledge is built on theory and observation. Black holes are laboratories for extreme physics, where our best theories break down. Scientists study them with telescopes and gravitational wave detectors, searching for clues. Each discovery brings us closer, but the mystery remains. The quest to understand black holes is a quest to understand reality itself. Will we ever know what happens at the singularity? Or will black holes keep their secrets forever? Science is a perpetual adventure into the unknown. Black holes challenge us, ignite our imagination, and remind us how much we have yet to learn. So, if you had the chance, would you take the plunge into the great unknown?